Today we're solving two-step inequalities, and the most important thing to know about solving two-step inequalities is that you solve them the same way that you solve two-step equations. So remember our order of operations? Well, we're going to use our order of operations in reverse because we're not solving for our answer, we're solving for a missing part of our inequality. So when we go to solve a two-step inequality, we get rid of addition and subtraction first, then multiplying and dividing, then any exponential expressions, and then finally any parentheses. So let's look at an example. So in this problem, 5x minus 4 is greater than or equal to 11. The first thing I'm going to get rid of is the subtract 4, and I'm going to do the opposite to get rid of it. I'm going to add 4 to each side. So I now have 5x is greater than or equal to 15. The next thing I'm going to do to isolate my variable is divide both sides by 5. Since I'm dividing by a positive number, I don't have to reverse my sign. It's going to stay exactly the same. And I get x is greater than or equal to 3. So 3 is the most important number to put on my number line, but I'm going to put a few that are after and a few before 3. And when I graph this, I'm going to put a closed circle at 3 because 3 can be a solution. 3 can be equal to 3. So I get a closed circle. My solutions are also greater than 3. So I'm going to highlight going this direction. Make sure you even highlight the arrow to show that the solutions continue on and on in this direction. Let's try another. So in this problem, I'm going to get rid of the plus 4 first by subtracting 4 from each side. So I'm going to be left with b over negative 3 is less than 9. Now, to get that b by itself, I'm going to multiply each side by negative 3. Except when I multiply each side by a negative, I have to reverse my sign. So I get b is greater than negative 27. So negative 27 goes on my graph, a few things greater than negative 27, and a few things smaller than negative 27. I'm going to put an open circle at negative 27 because b cannot equal negative 27, so this is not a solution. But b is greater than negative 27, so anything in this direction I want to highlight, including the arrow, which signifies that my solutions continue on in this direction, even past where my number line ends. Let's try one more. So normally we get rid of addition or subtraction first, but this time our addition is inside parentheses. So we're actually going to get rid of this multiply by negative 7 first. And we'll do that by dividing each side by negative 7. So it cancels out here. When I divide by a negative, remember I have to reverse my sign. Now that my parentheses are the only thing left, I'm going to subtract 3 from each side, and I get x is greater than or equal to negative 7. So negative 7 goes on my graph, a few things smaller than negative 7, a few things greater than negative 7. I have a closed circle at negative 7. I see the equals here. Negative 7 can be a solution. And my x is greater than negative 7. So once again, everything in this direction is going to get highlighted. This can all be a solution. And I even make the arrow highlighted so I show that the answers continue on.